All right, we're taking a look at question 4.3b. In this one here, it has an object that's being, an object with a weight of 250 newtons is being pushed at an angle. The force applied is at an angle of 30 degrees above the horizontal and with 310, so that's my code. Now, I know the first inclination here is to make this, the object's being accelerated, so these two angles, these two forces are not going to be equal. And I know that the first idea or the inclination is to take this and make that equal to 250, but it's not. I'll explain to you a little bit later. The question wants to know what's the horizontal acceleration. So you want to write out the equation like this. Ma net is equal to the force applied plus the force of friction. And our goal is to figure out A net. Now a couple of things. I don't know what the mass is equal to. That's going to be a bypass. The force applied is going to be equal to cosine 30 degrees times 310. And then the force of friction we're going to equals mu times the normal force. So we'll do Fn. Actually, this is the equation here. I'll write it out like this. And then let's write down what we don't know. So I don't know that. We got cosine 30 degrees times 310 plus mu, which is given to us. That's 0.24. And I don't know Fn either. Okay, so let's first take a look at this part here. So we're just trying to figure out the horizontal. So I need to figure out fx here. Now to figure out fx, we just do cosine 30 multiplied by its hypotenuse here, 310. All right. Now for the mass. To figure out the mass, we're going to do this. The force of gravity is equal to negative 250, then Fg is equal to mass times negative 9.8. So the mass comes out to be just negative 250 divided by negative 9.8. I don't think I really need to show you that on the calculator. It's going to be 25.5. So that goes here. All right. So we have, and the other issue is going to be figuring out what the normal force is. So I'll do that on the other side. So the normal force, or F net y, is equal to Fg plus Fn plus Fy. Right, so let me go back to the drawing. When this object is being pulled at an angle, there is an Fy that also pulls up this way. So by doing that, it's taking some of it's like almost lifting the block off the ground. It doesn't have to necessarily take it off the ground, but it's taking away some of the work of the normal force. So by pulling it up at an angle, the normal force, the ground, does not have to push as much onto the object because you're doing some of the work while pulling this object kind of almost at a, upwards a little bit here with this force. Now, how do I figure out what this force is equal to? It's just sine 30 degrees times 310. And that's going to be some extra work that the normal force or the floor does not have to do anymore. So let's set that equation. So now Fnet. Fnet means that in this case it's going to be 0 because the object is not moving. They don't talk about it in the directions. So vertically it's not falling to the ground, nor is it being thrown up into the air. So we can assume that that's at equilibrium. Fg is negative 250. Fn is what we're solving for. And this is equal to sine 30 degrees times 310. So we're here to try to figure out Fn. So we have sine 30, make sure you're in degree mode when doing this problem, times 310. And then we're going to add negative 250. And the answer becomes positive 95 because the Fn, you just bring that negative 95 over the equal sign. All right, so we got Fn is equal to 95, which is a lot less than the weight. So they're not equal in this particular case because some of the work is being done, or some of the force is being done by this Fy, the person who's pulling. So now this becomes 95 here. All right, now we can figure out the rest of this problem. So we have, let's just solve for A net. So I'm going to do cosine 30 times 310 plus 0.24 times 95. And then, oh, sorry, change that. this is going to be negative because the force of friction is going to the left. All right. Now, yeah, so like if the force of friction is going to the left, so that's going to have to be a negative value. So we have 0.24 times 95, and that's going to be a negative number. And then we have cosine 30 degrees times 310, subtract 22.8, and divided by the mass of 25.5. So we get a net acceleration of 9.6. All right, so something to make sure that you don't make almost the same mistake I just did here is make sure that the force of friction is going to be negative because it's moving to the left.